As we start Chapter 7, we're going to be looking at how to solve systems of equations. That'll be the main idea of the whole chapter. But first we're going to start by solving systems of linear equations. In other words, what we want to see is where two lines intersect. So if you think about this, well, yeah, I guess I should do this. So if the solution to a system would be this intersection point here. So I have two lines crisscrossing. The place where they touch is their solution. And why is it their solution? Because any point that this point must be on both lines. It's the only place where this point is on both lines. So if a point is on both lines, it must mean that those two points or those two lines are touching each other. Now, there's some terms here that I actually don't use very often. I don't even have them memorized, so I don't care much about them, but I'll mention them. So it's an independent system if the two lines touch each other. It's an inconsistent system if they never touch. So if you had railroad tracks, do you see there's no way. So they'd be built with the same slope, up and over, up and over, up and over, up and over. These are parallel lines. So because they're built with the same slope but have different y-intercepts, well, if they have the same slope and different y-intercepts, they're never going to touch. That's called inconsistent. And lastly, it is a dependent system if the two lines are literally the same line on top of each other. Well, in that case, they're touching everywhere. Now we'll address some how to deal with this. We see this occur in an algebra problem, but again, just here's the idea. A system of equations is solved by the point where they intersect because it's a point on both lines. If it's on both lines, that must mean they must touch there. Parallel lines will never touch, but if it could turn out it's actually the same line on top of each other in which they would touch everywhere. So the most basic way to see if you can solve a system of linear equations is to literally just see if this point is a solution. We're just going to plug it in. We're going to see what happens if we put in the value 5 for x and y is 1 into both of the lines. So we crunch that down. We get 8 equals 8 here. So that's true. So in the first line, 5.1 is on that line because it tells a true statement. I put in 5, I put in 1, and it's telling the truth. Now let's put that point into the second equation. Well, it also tells the truth. 1 does equal 1. So in other words, this point is on that line. Well, if the same point is on both lines, well then those lines must intersect there, and it must be a solution to the system. So if we have it graphed here, that point is where the two lines hit. Now you can always pause this and try this on your own if you'd like. I'm going to drop it in here. So 5, maybe I am, 5 times 8 minus 4 times 5 equals 20. We're going to check this first one. Is this telling the truth? Well, that's 40 minus 20 equals 20. That's true. So we're okay in the first one. Now if it's true in the second one, then we know this is a solution. Now be careful, remember, if you drop something in, you sub it in, you put it in parentheses here. So this is 16 plus 1 equals 15. This is not true. So although it was true in one, it has to be true in both. The 0.85 is not a solution. It's only on one of the two lines and not both. All right, now in this section we're going to see, as we continue in the next videos, we're going to learn all the different methods in order to prove whether or not you have a solution to a system. But the first and most basic way is you can literally just graph them. Just graph the two lines, see if they intersect. Now, this is an easy way to do it, but the problem is that it's hard to graph these right and get the intersection points right. So while this is true, it's kind of difficult to do. If you had GeoGebra or something and we're allowed to use that, or Desmos, it's going to be easy, but so not all the time. So let's just graph them and we'll just do our best to see if we can see where they intersect. So I'm putting each of these lines in slope-intercept form. Remember, this is my slope, so my intercept here, b, is negative 8, so it hits the y-axis at negative 8. My slope is negative 2 over 1. We make it a fraction so we know how we're going here. Down on this line, my y-intercept is 1, my slope is 1 over 1. We put them over each other. Okay, So let's just graph each of these. Hopefully remember how to do this. So I'm going to start at my intercept here. We'll do this. The blue one will be this top one. So -8. So I don't want to spend a ton of time on this. This is the algebra 2 here, but so you'd go up 2, back 1, up 2, back 1, graph that line. Now we do the other one. We intersect at 1. So you could go up 1, over 1, up 1, over 1. Connect those dots. And if you graphed it right, you'd see they do intersect. They intersect at -3, -2. Okay, so we're going to try this one more time. Going to solve both of these. I'm going to put them in slope-intercept form. So remember how to do this. This is going to go become 2/5 x plus 5. Got to send that -5 to both of them. Okay, so there's one of my equations. I should have used the book's graph, but I forgot. Okay, so I've got okay, so I have my two equations. I'm sure mine is not going to work out. You know what? Actually, I'm going to pause it and show their graph. Hold on one second. Okay, I'm not going to try to graph these. Well, maybe I should. So hold on. I've erased everything. I'm going to have to show this again real quick. Okay, I'm sure it won't work out very well, but let's try it just to make sure if you're having trouble remembering how to graph. Okay, so I'm doing this top one. So my intercept is 5. So 2/5. I'm going up 2 over 5. Now I could go the other way, go down 2, back 5. Okay, so I get something that looks like this. Okay, let's try it again. So this one, my intercept is 7. So I'm going up 4 over 5. You could go down 4, 1, 2, 3, 4, back 5. Wow, in a miraculous turn of events, even though my graph is terrible, I think I got it. So -5, 3 would be that intersection point. I think I actually found it. But again, the graphing method, the problem is that it's very difficult to find the spots unless you have a ruler out and you're doing it very carefully, or using some kind of graphing calculator. But that's the idea. The most basic way, if we just graph them, we can literally see if they intersect each other. Now in the next sections, we'll learn some of the other approaches that are a little more mathematical.